All right, in this section, we're going to be looking at other types of equations. So thus far, we've mainly focused on linear equations and then quadratic equations. Then we talked about their applications. So that has been, and that will be most of the types of algebra problems that you work will involve those two big categories. Linear, where x is to the first, quadratic, where x is to the second. So this section addresses other types of things that can come along that aren't exactly quadratics. So the first topic we're going to start with is what is a rational function. So whenever we're solving the rationals, that means that there will be a fraction involved. So if there's a fraction involved in your equation, the first thing you would want to do is try to clear your fractions. So what you can do is you look at all of the denominators and you say, what's the least thing all of these denominators will go into? In this case, it's 6. Then you times each side of the equation by that LCD. The LCD of the equation is 6. If you truly pick the right LCD, then when you distribute it, this is like 6 over 1. So when you times by 6, if all of these denominators divide into that evenly like that, you won't have a denominator any longer. You'll get rid of the fractions. So 3 times a would be left. But then you have to go back to the 6. You're distributing 6 to every term. So then when you distribute 6 to the 5 6, the 6 and the 6, when you multiply, and distributing is multiplying, when you multiply, those completely cancel out diagonally, just leaving the 5. So, you know, it's nicer, easier to solve equations now that you don't have the fractions involved. Same thing must be applied here. As we know with algebra, what you do to one side, you have to do to the other side. So on this side, we'll distribute the 6. So 6 times 1, 6. And then 6 times a over 3. Here we have the 3 that's diagonal to that 6 over 1. So again, you're multiplying there. So 3 divides into the 6 2 times. And the reason that is when you're multiplying fractions, you can cancel out the diagonals. So 3 divides into 6 twice, then 2 times a. And then what's left on the bottom are really 1s. A 1, when we mark that out, times 1, or 1 in the denominator. So there's no real fraction left. So now we've got a linear equation that we can solve without the fractions. So I want to get my variables to the same side. So minus 2a bring to the left side, making a total of 5a's. Minus 5 bring to the right side, making it plus 5 or 11. Last step, divide by what's on your variable. And so the solution here would be 11/5. All right, let's try that again. We've got a different variety of that same type of question as we go. So let's look at number 2 next. So again, all of these will have some sort of fraction involved for this situation. So what we recommend is you get rid of the fraction by timesing by the LCD, first thing. And as always, pause the video, try this on your own before coming back in to watch it. So this last fraction, I'm going to put it over 1. And now looking at this, it's not just a number. This time we've got the algebraic fractions, the algebra in the denominator. So when we think about the LCD, it actually could be an easier problem because you know, whenever we're dealing with numbers like 3, 6, 9, 12, we have to think, what do all those fit into, and kind of go through the arithmetic. Well, with algebra, you can simply say you need 1 of every letter, basically, 1 of every type of term. So we'll need the 3, and then we'll need this x minus 1, and then 1 we don't really have to deal with. So the LCD will be the 3 and the quantity x minus 1. So that would be my LCD, or what all of these denominators will fit into evenly. That's what you're trying to do. So we times that to the left side. So the right side also will need that applied. All right, so then we distribute. That's what allows us to do this. The distributive property is then applied because that's multiplication. This is really over 1. So diagonally, the 3's cancel, and you've got x minus 1 times 3x minus 1. I'll have to FOIL that out in a minute. Then when we distribute it here, you've got to bring back the full LCD. So bring that back, or at least know that's there. All of this then applied here, the x minus 1 parts cancel, you see. So you've just got a 3 times 2x, or 6x. Again, no fractions, it gets rid of the fractions. On this side, 1 won't cancel any of that out, so it's just multiply all that together in any order. Probably would look best in that order. That's the way we're used to seeing it. And now we have a solvable equation without the fractions. The fractions make it really hard to solve in that form, so we always recommend getting it to non-fraction form. So this needs to be FOILed. This side needs to be distributed. And what you're going to see, it looks like it could be a quadratic equation. Quadratics have the x squared, so I proceed like it's going to be a quadratic, but you may notice when I bring that 3x squared across, they cancel each other out. So it loses its quadraticness, right? It looked like it could be, but then the quadratics cancel out. So what have we got? Minus x, minus 3x, and minus 6x. All of those are combinable to minus 10x, and then the plus 1. And then on the right side, what I have left is minus 3x. Now I'll get my variables to one side and constants to the other. I would bring the minus 10x to the right and make it plus 10x. Negative 3x and 10x is 7x equals 1. Then divide by what's on the variable. Divide by 7 for a solution of 1/7 there. All right, and again, we could check that, make sure it works in the original problem, although this is not an easy check problem. But if you can see the original problem up here before we did all this work, we should be able to always check our solutions back in and make sure it works. Now, the reason that's maybe more important on this particular type of problem is if you would get an answer that causes a 0 in the denominator. For example, if the solution would have been x is 1, 1 minus 1 would have made that denominator 0, we could not have used it. But here, there's no problem with that. But again, you could check, make sure. All right, so try the next one. Again, always actively learn with me and try it on your own before watching the solution. Somehow it helps our brains if we do a little bit of our own kind of evaluating it, get involved in the problem before I go over the solutions. All right, so again with these fractions, so we want to think of this as being over 1 and this as being over 1. So there's really only one type of denominator, this x minus 2, and it's repeated here. So it's the same denominator, and that will be our LCD. That's the one type of denominator, so that is the LCD. So I'm timesing that to this left side, and then I'll times it to the right side to keep the balance. So whenever I multiply or timesing is distributive. So it really just means every single term gets this applied. So whenever I distribute here, 1 will not cancel anything out. We'll just times those two parts together. And I can distribute that in a minute. But this one's nice. Whenever I distribute it here, the x minus 2 is diagonal. Remember, this is over 1, and you're multiplying, so the diagonals divide out, or at least reduce, and you just have the minus x. On this side, distributing as well. Right here, the x minus 2's cancel, just leaving a 2. We got to use that again here, though. So whenever we times it to this one, the 1 doesn't reduce it any. This is over 1, so you just got 1 times 1 on the bottom. That's why you don't have the fraction anymore. But we'll have 2 times quantity x minus 2. And now we have an equation equivalent to that one. These two are exactly equivalent equations, believe it or not. You know, we didn't do anything to change its value. We just changed its looks. So then we want to distribute. Now notice this 2 is just brought down. This is the distributing 2. And the way to get good at little things like that is just this practice as you're going through, and we're still in the first chapter, so you're getting your warm-up still going of practicing this. So the more you do this, it gets ingrained in you. You just become second nature. But then we see we've got a quadratic equation. I could go ahead and say negative 2x and negative x is negative 3x. Just simplify each side. This side has a 2 and a minus 4, which is negative 2 in either order. But it does reduce each side, simplifies a little bit. Okay, then I can see it's definitely a quadratic equation, x squared. So if it's a quadratic, and I'm not going to lose that quadratic term, bring everything to one side. Getting that in standard form means bringing the 2x across, making a total of negative 5x. and bringing the minus 2 constant across, making it plus 2. Okay, so then, unless I've made a mistake somewhere, that does not factor. I'm going to kind of look back through it. You look through it with me too, because I thought this one did factor earlier. So let's see if we can spot a mistake. If there is one, it may be okay. But we're going to check our steps. I'm going to make sure I wrote the problem right. That's one thing I very much could do. X minus x over x minus 2 plus 2. Okay, looks like I did that. Then my LCD is the x minus 2, kind of just reviewing our steps. Then those two multiply together. And then that distributes to x squared minus 2x. That looks okay. Here it cancels. You just have the minus x for a total of negative 3x. That seems okay. On this side, I'm timesing by x minus 2. On this first term, it cancels, just bringing down a 2. Whereas here, these multiply together because there's nothing to cancel it out. So 2x minus 4. I think that's okay. So that gives me 2x, and 2 and negative 4 is negative 2. Brought over makes it plus 2. The 2x brought over. Okay, I think I'm okay. So anyway, as far as I can tell, that seems like the correct steps. And I'll tell you why I'm pausing here is because I thought I had one that we could factor and find the solution that way. But this one does not factor. You can try to factor it. X times x is x squared. Minus 2 times minus 1, and that is the only way to get a positive 2 on the end and a negative in the middle. That does not FOIL to give me a negative 5x in the middle. There is no way to use the factoring method on that. So that means we're going to do the quadratic formula. So anytime it's not factorable, it forces you to use the quadratic formula. All right? And so we could plug that into the negative b plus and minus the square root of b squared minus 4ac all over 2a and find our solution. Again, pause the video to practice that, please, anytime we do these types of problems. It's good for you to actively learn with it. Okay, and I'm going to erase a little bit to make some room to work that with you. So the solution would be the negative of b makes it positive 5 plus and minus negative b squared, which makes it 25 minus 4 times the a value times the c value, all over 2 times the a value. That's 5 plus and minus 25 minus 8 will be 17 over 2. And then that would be the final. You could not reduce that really. The 17 does not reduce in this radical, and then that would be the way you could leave your answer. All right. And again, we should always be on the lookout if our solution comes out such that it would have been a 2, which it didn't, but if it would have been 2, 2 minus 2 would have caused a 0 denominator, and we would throw that answer out. All right, one more. Number 4. Again, look at that one. Get ahead of me on that. This is on your handout. Attachment with this video. Okay, number 4, we have 3x plus 2 over x minus 2 plus 1 over x equals negative 2 over x squared minus 2x. So first step is try to find the LCD so we can times both sides through by that. And on this one, it just so happens this last one will factor into x times x minus 2. Just so happens. Sometimes these contrived problems. But this is exactly this times this. So that would be our LCD. Again, your LCD is just what everything will fit into. So we want to times both sides by the LCD x minus 2. So this side as well. And then whenever we distribute, the x minus 2 part cancels, and it's just x times that. When we distribute here, the x's cancel, so it's x minus 2 times 1. And then lastly, this is the nice part, all of that cancels. It's diagonal and just brings down the minus 2. So it looks like we're going to have another quadratic equation when we distribute. And then you want to put that in standard form. Bringing the -2 across will make just 0. And then we can factor that, or we can use the formula, the A and the B. Now actually you could divide by 3 since both of those are 3's and make this easier. It would be x squared plus 1x, and then 0 over 3 is still 0. Now this will actually factor by just factoring out the GCF of x and have x plus 1 like that. Notice if you distribute, it's this. So that works. Then you set each part equal to 0, giving you 2 solutions, 0 and -1. Now here's an example where we cannot use the 0. If I plug in x is 0 here, I'll have 1 divided by 0 when I check. That's undefined. But -1 should be okay, and we can check that in. So we only circle the ones that are usable, and this answer gets thrown out. So always check your answer back in and see if it makes sense in the original problem.